Okay, let's start to get started. So now today we have 3 notebook, and we actually only have 2 hours, or I'll do a little bit faster. And but don't worry, we actually also have some data cam. Your homework is actually in the data cam, so that also have some explanation there for dplyr. Okay, so as I told you that the dplyr is designed for us to manipulate the data within data frame easier, right? So let's just take a look at them. Let's see it here, right? So within this notebook, I actually put a flower before every dplyr functions that I want to introduce, right? So the function of dplyr is actually very straightforward and very easy to understand. So actually you can go through it actually quite efficiently. Okay, so now the first important function that we want to introduce is actually called select. It helps you to select columns. See, originally this D data frame has 40 columns, right? Columns is sometimes call them variable, right? So these two terminology are used interchangeably, right? Okay, so we have 40 variable or 40 columns, and sometimes we don't want to have that many columns, right? Sometimes we only need to have a few columns, so it's easier to manipulate, right? Easier to manipulate. So if you want to select some of the columns from a data frame, you can call the select function. Okay. Okay. As you can see that this dplyr package, usually we can put the data frame as the input. Okay, and now you want to select the 1, 2, 3, 4 column out of dplyr, out of this D data frame, which has 40 columns. So after we call the select, as you can see that now we have a table of 3, 1, 3, 4, which is the same length as D, but actually we only have 4 columns instead of 40 columns, right? So this is very straightforward, right? You just write down the column names and then call select, and you will have of course if you do not this is an expression, right? A pipeline is an expression. So if you want to set this pipeline into a new data object, you just put the equal sign here, right? And put the expression on the right hand side, and in the left hand side we have this a new data frame name. For example, I name it D1. Okay, so after I execute this code chunk, you should see a D1 data frame in this area. See, we have D1, right? So, and D1 we have only 4 variables, as you can see, right? So this is select. The first function of dplyr is select. Help you to select some columns out of data frame. And the second function I want to explain is called arrange, right? You can arrange the data frame by population, and in D4 it will arrange this data frame in ascending population, which from small to large, right? Ascending. By default, the arrange function call would actually arrange the data frame in the ascending order of population. Okay, so after I do that, as you can see that the population is in ascending order, right? Okay, so if I want to like arrange the data frame in descending order, then I put a descending. I code descending population and then arrange. Okay, so it's kind of like arrange D1 by descending population. Okay. Okay. So this kind of like arrange D1 by descending population, and you can see the result. Right. Right now it's like in descending order. So the largest county, because it's in descending order, right? So the county with the largest population will be in the first column, in the first row, right? So which county has the largest population in the United States? Which county? You can see it here, right? The county name is Los Angeles, isn't it? Right? So Los Angeles is actually a county, and it has like more than 10 million population there. Okay, and the second one is Cook County in Illinois. The third one is Harris, right? Okay, so arrange is kind of like ordering, right? Instead of doing like instead of calling order to do a index and then put it in this type of indexing format, using the dplyr arrange call, you actually can write the program like speaking English, right? Like this one, we are arranging we are arranging this D1 data frame by descending population, right? You're arranging D1 by descending population. So it's kind of like very intuitive, right? And so you can use sort, you can use order, you can use arrange, but usually for data frame manipulation, when you use the dplyr, you are using this arrange function call. It will make the code a lot easier to read and write, right? And the next function I want to introduce is this filter function. Okay, as you can see here, the filter function will help to select data row. Okay, the select function is help you to select column, right? But the filter function is actually help you to filter row or select row by conditions. Okay, by your specified condition, right? For example, if I want to like in this D1, I only want to filter out the county within New York State, and also had an unemployment rate lower than 8%, right? Okay, so in this filter function call, you actually just type in the condition that you want to filter the rows, right? So from time to time you want to select row, and you select row, you select it by using condition, isn't it? Right? Okay, so in this example, I actually filter out the county within New York State, and also the unemployment rate is below 8%, right? So I filter out all of this row, and then I arranged these rows by descending population. Okay, so you can actually do a lot of dplyr function call and pipe them together, right? So the dplyr function call is also is usually take the table as input and it also output another table, right? So you can chain them together by using this pipe operator. Okay, so first of all, I filter out 39 counties which satisfy these conditions, and then I arrange the county that satisfy this condition by descending population. Okay, so in this way you actually can like do a data manipulation in a much easier way, and you can read it very easily, right? In compare with like using very complicated indexing and function code and built-in function code type of things, right? So it's easier, make it easier to write code. Okay, so the next function that I want to introduce is actually the mutate function. It helps to define new columns, right? As we can see here, that originally in D1 we have like 1, 2, 3, 4. We have 4 columns here, right? And sometimes you want to define small columns, okay? And you can do it this way. Say, for example, I want to create a new column called unemployment rate, okay? And this is actually 100 times unemployment rate and divided by population, right? This is one way to count the employment rate. And then I want to see the population in thousand. I want to see the population in million. So I simply divide it by, right? So usually when you use mutate, you are using the existing column and do some arithmetic calculation, right? And with that, you can define the new, you can define the new columns, okay? So if I do that, as you can see that, the outcome would be 7 columns, right? At length. So okay, 1, 2, 3, 4, 5, 6, 7, right? So and this 3 column, let me see it here. Maybe it's easier to see. These 3 columns are new columns, right? In the beginning, we only have the D1 only have 4 columns, right? So you use mutate, okay, and by do some arithmetic calculation, you can define some new columns within the data frame. Okay, so so up to this point, we already learned some basic function of dplyr. This is how it works. Very straightforward, right? So you can actually, first of all, you can like filter out the columns. Filter out the records, filter out the rows by condition, okay? And if you have more than one condition, you just put a comma and then put the second and third condition here, right? And all of the condition, all the rows that satisfy the condition will be filtered out, right? And the second thing is select column, okay? And usually you will select column by column names, right? Okay, so it's very straightforward. And the third thing is you can create new columns by mutate. Okay, usually in the mutate you can mutate more than one variable in a mutate code like here, right? In this mutate function code, we actually create 3 columns at once. Okay, this is very important, especially when we are dealing with the real business data, right? If you are using the R built-in syntax, you will need to write 1 line of code for this one, 1 line of code for this one, another 1 line for this code. But in this mutate function, you can actually like define more than 1 column at a time, right? It is the advantage of this mutate, and it makes the code a lot easier to read, right? Because I'm using D1, I'm calling mutate to create 3 new columns, and the definition of these 3 new columns is actually just like using the existing column to calculate the new column, right? Okay, so up to this point, we already see the advantage to use dplyr for handling data frame. First of all, it is very similar, right? The benefit of using dplyr are, first of all, is similar to human language, right? Okay, and second, it can select several variables at once. Okay. And the third one is it can arrange filter condition, many conditions at once, at one time, right? Okay. Another important benefit of dplyr is that most of its function take a table, it call it table, right, as input, and it also the function also would create table, right? So that make it very easy to like chain them in with this operator, right? So you can use a lot of dplyr function and chain them together to help you handle with complicated query, right? Okay, so so because they always produce table data structure, so it makes it easier to chain several operations together with this pipe operator, right? Okay, so so it makes the data processing in a similar way that would produce goods in assembly lines, right? So with this dplyr and its set of functions, when you chain them together, it's like you are processing data in a assembly line, right? Okay, easier to understand and make it easier to implement complicated data process logic, right? If the data processing logic is complicated, you just chain the function code, right? So and every function code just do a simple job, and when you chain them together, you can do a comprehensive, a sophisticated process data manipulation, right? This is the basic idea of dplyr. Okay? So any problem up to this point? No problem, right? Okay. So let's see some other useful function in dplyr. Okay. Now we have a function called con, and con is a very useful function. It's kind of like the combination of table and tapply, right? You use a lot of table and tapply when you are doing homework, right? Okay, and in dplyr, this con function, you can use it like table, or you can use it like tapply. You can use it both ways, right? Okay, the first way to use con is actually you simply give the entire table as the input. Okay, so as you can see that when you do a con, you actually just count the number of rows. If you give it a data frame, give it a table. It just count the number of rows, okay? Okay. But if you give it a data frame and also a column name, okay? If you call count with a table and also a column name, it will count the number of rows by state, okay? So in this case, the number of rows within the state is the number of county within the state, isn't it, right? So if I call count with D and state, then for every state, I will see the number of row. And in this case, it's the number of county within that state, isn't it, right? So you can count the number of row, number of, actually you can see that it can count state, and then for each different state, it will count the number of rows that within the state, okay? So this is like table, right? This is like doing table of the state, but the output is different. If we do for example, if I do a table D state, what's gonna happen? You can see that it is actually, the output of table is actually a vector, right? Isn't it? Okay? It's a very lengthy vector, right? But the output of count is a table. Okay? It's no longer a vector. It actually is a table of two columns. The first column is the state name, of course, right? And the second column is the number of rows of this state. See that? Okay? So it's very similar to doing table, right? But actually you can like, but the output format is different from table. If you do table, you will see a vector. But with count, the output is a table of two columns. Okay? Now, you actually can count it with multiple variable. If we count D with state and metro, then let's see what will happen, right? As you can see that it counted Alabama state has 29 county is in the metro area, and it has 38 county is in the non-metro area, right? When we do it only by state, it counts that in Alabama we have 67 county, right? But if I count it by state and also by metro, it actually would say that this 67 is made up of 29 of them in metro and 38 of them in the non-metro area. You see that difference? Okay? So in this way, you can see that it's function like doing table, but the output is actually is also in the table, in the data frame kind of format, right? And it can also do a kind of like the count function has two optional argument. The first one is called weight, and the second one is called sort, right? If I want to like sum the population by state, okay, and I want to sort the output by descending number, right? I can call the count function in this way, right? First of all, I specify state, and then I specify weight equal to population. If you do not specify weight, then it just count the number of county within the state, right? But if you put the weight argument within this count function, it would sum the population for all of the state within this county. Okay, so instead of just counting the number of county, you can use this weight to specify the column that you want to do the summation. Okay, okay. So count can also use this weight operator to like sum the number of population by state, and also sort them by the descending order, right? As we can see here. So because we already summed the population within the state, right? So the n is no longer the number of county. It's actually all of the population within the state. So which state has the largest citizen in the United States? Say louder. It's California, right? California has like 38 million people. And the second largest state is Texas, right? It's like 26. Okay? So actually the United States in the beginning, people are all live in the kind of like in the East Coast, right? But as times the West Coast is the population in the West Coast is getting larger and larger from time to time, right? Okay, so now we are introducing that the count. You can count the number of rows. That is one way to use it, and then you can use it to kind of like summarize a column by state. Okay, in this case we are summarized population by state. So all of the population within the state will be summed together, right? Okay, and then you can also do a sort. So it's very, very useful, right? If you want to use the built-in function, you need to do a lot. You have to do maybe 2, maybe 3 statement to do this. But by using the count, you can actually do the summation and sorting at once. Okay, group summation and sorting at once. Okay. So this is the count function. It's a very useful function. Okay. Now the next function that I want to introduce is called summarize. Okay. This is not the same as summary. Okay. The summarize is used to like make statistic in a single function call, right? As you can see that if I put D and I can summarize the total population, and I need to give it the expression, it actually, summary would actually create a new column, right? You can define column, but the column usually it is used to summarize the entire data within this, to summarize data in the columns of a table, right? So, for example, I want to see the total population in the United States. I can sum the population for all of the county within D, right? And if I want to see the average population per county, I can use the average, right? And population. See? And as you can see that after I calling summary, the output is again a table, right? But this table has 2 columns and only 1 row, right? Because I'm summarizing the entire data frame, right? So I summarize the entire data frame into a few columns. Okay. Now, in practice, this summarize function usually work with this group by function. Okay. Okay. So usually when you do summarize, of course you can summarize the entire data frame, right? You can summarize the entire table, but you can also summarize by state. Okay. For example, if I do a D and I group by state and I do a summarize, you can see the result, right? Now the result is that for every state, I will summarize the number of counties, I can summarize the total population, I can summarize the average population for every state, right? You can see that? So group by summary will help you to summarize several new summarized variable. This new summarized variable, you can create several summarized variable by groups. Okay. If you call summarize directly out of directly from a data frame, you actually only see 1 row. Okay. But if you group the table by some column and then do summarize, then every group will be summarized as a row. Okay. So in this way, you can actually summarize a lot of things, right, by group. Okay, in a single group by summary type of syntax. Okay. So if we take a closer look at this this syntax here, when you do if I select D and do Control Enter, you can see that it's actually a table of 3000 times 40, right? And then if I call the group by here, if I run the pipeline to the group by, after the group by, take a close look at here. Take a close look at here. The difference is, it actually, the data is the same. It's still 3000 by 40. But right now, the data has a group structure within the data, right? So this group by function call does not change the data. Okay? By itself, it does not change the data. It only group the data. It's like the data is the same, but after you calling this group by, as the output of this pipe, the table has already been divided into 50 groups, and the summary would actually work on each of this group. Okay? So when you call the group by, you actually divide the table into groups. Okay? And the subsequent function, okay, the following function is no longer working on the entire table. It will work on each group of the table, right? Okay, so this group by function will help you to kind of like divide the table into group. By itself, it did not change the data, but for the subsequent function call, It's no longer working on the entire. When you have this group structure in the table, the subsequent function will work on each group of them. So the summary will do 50 times, and every time you will produce a row. Okay? So when I do the summary, see, it becomes a table of 50 times 4 rows. See that? And the group, and you can see that also the group attribute is gone, right? It's no longer needed, right? Because every group is already summarized into a row. So the group structure is no longer required. So that that group, the grouping structure is removed. Okay? Let me show it again. If I do a group by, you can see that the data is still 3000 times 40, but that table is divided into 50 groups. Okay? And I call the summary. It actually, the summary function will work on the each group. So the summary will do 50 times. Okay? And every time it will produce a row. Okay? So after I do it here, let me make it simpler so it's easier to see, right? Let me take this arrange away. You can see that it become a 50 times 4 table, right? Okay, because they are 50 groups, and every group is summarized into a row, right? So the group structure is no longer required. Okay, so the group structure is gone. You no longer see the group structure. Okay, you see that this is how group by and summary work together, and it is very useful, as we can see in the Tafang case later. It's a very, very useful things that we need to do in dplyr. Okay. Now, actually, you can use tapply to do this, right? I can summarize the number of county by state. I can summarize the say if I want to do tapply, you would need to do this like for example, I want to summarize the population. Okay, and then say what I want to. State, and then I want to sum. Okay, if I use tapply, I can also summarize the population by state. I can also take the average, right? But if I do it this way, I actually need to use two different expression, and I also need to combine these two expressions into a table, right? So if I want to like kind of summarize more than one things in one function call, the group by summary will be a lot easier than doing t-apply. Because using t-apply, you need to do every column one at a time. And you also need to combine all of the column into a table, right? Okay. So this group by summary is more easier and more convenient way to do a group summary. Sorry. Okay. Now there's question here, so you can actually try to answer them, right? So t-apply and group by summary, they are different, right, in many ways. And group by summaries is actually, usually it's actually easier to do, okay? And when you do group by summary, you can actually have multiple variable, grouping variable, right? As we can see before, that you actually can group by state and also by metro. And when you do that, you will see, so far you have state and metro. You have two grouping variable, right? You group by state and metro. And right now you have 97 groups, right? United States have like 50 states, right? And some state might not have metro area. For example, like Alaska. In Alaska, there's no metro area, right? So this 50 state, you only have like 97 state metro combination, right? Okay, so it's like if you group by more than one group variable, you will have more group, okay? And after summarize that group, as you can see that I put a group equal to drop here, I can actually like, if I do not use this this optional argument in summary, the output will be something like this. It would give you a warning saying that the output is still has the group structure. Okay. Well, usually the group by summary, as I told you earlier, right? It will remove the group structure, but it will actually only remove the last group variable. Okay. If we have more than one group variable, it's actually only remove the last group variable, right? The last group variable, which is metro, right? So when you do a summary, a group by summary call, the result is actually still has the state group structure here, right? Okay, so you need to be careful. If you don't need to use this group structure, then you can use the group equal to drop, and then you will no longer see the warning, and then the group structure is removed, right? So when you are using multiple grouping variable in this group by function call, you need to be careful, right? Because after the summary, only the last group variable will be removed. The structure, the group structure is there, and it's also influence. It will influence the function call, the subsequent function call. Okay, if you do not want to have that group structure, you can drop the group structure by using this argument, this extra argument in this summary function. Okay, that is important things, right? That we need to know. Okay. We have some time, so I'll do it quicker here. Okay. Some time pressure here. Okay. So The next one I want to introduce is the top n function, right? A simple example can it will be easier to explain that by directly by example. For example, if I want to select the top 3 county by population, right? Okay. If I select from D1 and I want to select the county, the top 3 county with the largest population, okay? Top n is used to select the top n row with the column name, right? So in this case, I want to select the first 3 county with the largest number of population, right? Usually we want to do that, right? So you can specify n equal to 3. So with that, I select the 3. I select the 3 county with the largest population out of D1, right? Okay. Now if we try to do it by, if I put a group by here, right? Now after the group by, we have a group of 50, isn't it? Right? So within the 50 state, within the 50 state, it would actually select the 3 county with the largest population. You see that? Okay. So with the top n can also work with group by, okay? Or I can say that the group by would actually like chop D1 into 50 groups, and the subsequent function is no longer work on the entire table. It will work on each group. Okay. So when the function top n work with group by, it will actually select the 3 county with the largest population from each state. Okay. So I think it's quite straightforward, and actually there are some more enhanced syntax that we can use in dplyr, right? For example, in this select function, you can actually select a column by its name, okay? And you can also select a range of columns. For example, if I want to select state, county, and I also want to select this column, this range of column, as we can see that in B. Here I'm selecting state, county, and I also select drive, because I'm using this syntax, right? It means that I want to select from drive to work at home. Okay, this 1, 2, 3, 4, 5, 6. I want to select from drive to work at home. So I can select a range of. It's quite handy, right? In this syntax, you can select, and you can also select by the column name. For example, I say I want to select state, county, and also all of the column that with the column name has the work. Okay, so after I do the select, see, I can see it here. It's easier. So all of the column name with work. For example, work at home, private work, public work, family work. Okay, all of the column names that has work will be selected here. Okay, so this is another handy way that you can use select. Okay, actually you can also use the selection in the negative way. Okay, so in this selection, I want to exclude all of the column that has the work in this column name. Okay, so as you can see that because we have 4 column with the with work in their column name, right? So if I do this, I exclude this 4 column, and then I count the number of row, the number I count the number of column, and then the number of column is reduced from 40. So I exclude this 4 column that with work within them. I only have 36 left, right? Okay, so and also I can have a function called rename, right? Okay, if from time to time you when this variable name is too lengthy, you would like to rename it, right? So you can call the rename function to rename the unemployment column, and rename is column name from unemployment into unem, right? So that's the way to use unem, the rename function. And also, actually the select function is very flexible, right? You can actually select column, and you can also do a rename within this select, right? Simply by this is the original column name, and then I with this syntax I can rename it, right? So you can change order, you can rename. The select function is very flexible. Okay, and the last function that I want to introduce is this transmute. Okay, the transmute is if you use select, you can do rename, but you cannot do computation. Okay, if you want to do computation, you can call the transmute. So within this transmute, you can select state. Again, you can select column, and you can also define new column. Okay, so this transmute is something like select plus mutate. Okay, you can select existing column, and you can define new column in a single function. Okay, so select by itself is very flexible, and you can also combine the select and mutate function with this transmute function, so you can select column, and at the same time you can define new column in the same function code. Okay, so with all of this enhanced function, it will make the data frame manipulation a lot easier. Okay, by dplyr. Okay, now it's already 11:05, so let's take a shorter break. Okay, so let's try to get back at okay, let's just still take a 10 minutes break and start the course at 15 after 11. Okay.